Now let's look at this question, and here it says that a 600 microfarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 600 microfarad capacitor. How much electrostatic energy is lost in the process? Now, first of all, what we need to do here, let us write out the first capacitor is 600 microfarad, the second 600 microfarad, and the volt is 200 volts. Now the electrostatic energy is given as 1 over 2. Now in relationship to capacitor and V, you have CV squared. Okay, now let us now find the electrostatic energy for the first one, on the first capacitor, which is 600 microfarad, when it was charged. So here you have 1 over 2 times 600 times 10 raised to the power minus 6. Now this 10 raised to the power minus 6 is actually the farad, okay? Then times the volt, 200 raised to the power of what? 2. Then you get to have this will now give us 2 here, 2 here, 300. Then here you have 300 times 10 to the power minus 6 times 200 raised to the power of 2 should give us 40,000. Okay, now let us put all these to index form. This is 3 times, now how many zeros? 1 2 3 4 5 6. All right, now 3 times 4 here is 12. Now times 10 to the power of 6, 1 2 3 4 5 6. Now times 10 to the power minus 6, which is this. Then when we eliminate, so the energy, electrostatic energy it acquired after being charged is 12 joules. Now, which implies it is now unplugged or removed from the source. It is now connected with another uncharged what? Capacitor. So now since we are not told it is parallel, automatically it should be in a series. And when capacitors are in series, here you have 1 all over. Let's look for the combined capacitor. So since they're in series, it will now be 1 over C, which is the combined capacitance, over 1 over C1 plus 1 over what? C2. Then this will give us 1 over 600 plus 1 over what? 600. Okay, so since they have the same denominator, 1 plus 1 all over 600, which will give us 2 all over 600, which is 1 over C. Then our C will now give us 600 all over what? 2, which will give us 300 microfarad. Now let us now calculate the energy on the static energy on this. So here you have 1 over 2 CV squared. So here you have 1 over 2 times this 300 times 10 to the power minus 6 times that's the charge. That is still 200 all is power 2. So this will give us 300 times 10 to the power minus 6 times the square of this 200. The square of 200 will give us 40000 for 1 to 3. Then all over 2 here 1, 2 here 2, then 0000. So our energy will still be 2 times 6. 3 times 2 here is 6. Then times how many zeros? 1 1 2 3 4 5 6. Then times 10 to the power minus 6. This will cancel this, so we're left with was 6 what? Joules. So this is actually the electrostatic energy after it was connected to this uncharged capacitor. So to that end, the energy lost will then be, that's 1. Let's say this one as 1, and let's take this one as 2. 1 minus 2, which will now give us 12 minus 6 joules. Alright, now let's look at this question, and it says, now two parallel plate capacitors of capacitance 2 microfarad and 3 microfarad are connected in parallel, and the combination is connected to a 50 volt DC, that is direct current source. Now draw the diagram of the arrangement and determine the charge on each plate of each capacitor. Now potential difference across each capacitor. Now combined energy of the capacitors. Now for the first one, let us draw the circuit diagram. Now take note, 2 parallel. Now for the fact that it is 2 parallel, so we say okay. Now let's say this is the first one, C1 and C2. Now are connected in parallel, and the combination is connected. So the combination of this with DC, so of 50. Alright, so this is for the first one. Now the charge on either plate of each capacitor. Now let us take note that the charge equals was CV. Okay, now take note, now for the fact that they are parallel, now it's the same volts that travels around, but we definitely have different charges. Okay, so right, we have this different charges but the same volt. So to this end, Q1 we have our C1 and V, since we have a common voltage, so potential difference. So here we have Q1, then C1 is 2 microfarad times 50, so here we have 100. Then Q2, I will C2V, that will give us 3 times 50 equals what? 150. Now for the potential difference across each capacitor, these are number 1 and number 2. Now since they're in parallel, so the answer is just 50. Okay, so for number 3, we have the combined energy of the capacitance, of the capacitor. Now first of all, what we need to do is to find the effective or the combined capacitor. So that will be C. Now since they're in parallel, you have C1 plus what? C2. Then this will give us 2 plus 3, which will give us what? 5 microfarads. And for the energy, E equals to 1 all over 2 CV squared. Now 1 all over 2 times our combined capacitor is 5. Now take note that 10 raised to the power minus 6 times 50 times 50. So here we have 1 all over 2, 5 times 50 times 50. That should give us 50 times 50 will give us 2500. Now 5 times 2500, that should give us 12500. Now times 10 raised to the power minus 6. Okay, now 2 here 1, 2 here 6, 2 here 2, and 1 in 10 is 5, then 0. You end up having 6250 times 10 raised to the power minus 6. Now here you have 1, 2, and 3. So this is minus 3 here, and the energy was 6.25 times 10 to the power minus 3 joules. Alright, and that's the answer. Thank you. Now let's look at this question here, and it says that the plate of a parallel plate capacitor 5.0 times 10 to the power of minus 3 meter apart and maintained at a potential difference of 5.0 times 10 to the power of 4 volts. Calculate the magnitude of the electric field intensity between the plates, force on the electron, acceleration of the electron. Now, and here's of the constants that we are giving: the electrical charge and the mass of the electron. Now, first, the electric what? The electric field intensity. Now, for the electric field intensity, we have that E equals V all over what? D. That is the volts divided by the distance. So what we need to do here, plug in the value of V. Sorry, let me write out the parameters. The distance D is giving us 5.0 times 10 to the power minus 3. Potential difference V is 5.0 times 10 to the power of 4. Okay, and we're giving that E 1.6 times 10 to the power minus 19, and the mass of the electron 9.1 times 10 to the power minus 31. Okay, I guess that's all right. So here, potential difference 5 times 10 to the power 4 all over the distance 5 times 10 to the power minus 3. Now this actually gives us 5 in 5 here, you have 1, then times 4 minus 3, that is this here. Then our final answer E now becomes 1 times 10 raised to the power of what? 7, because 4 plus 3 will give us 7 volts per meter. And the next one, we are told that find the force on the electron. Now at this particular point now, we'll look at the electric field force. And for the electric field force, F in relation to the charge and electric field, here you have QE. Okay, alright, that is the product. The electric field, the electric force field equals to the product of the charge times electrical field. So our charge here is our charge, that is Q here. That'll be 1.6 times 10 minus 19. Okay, let me just not give the same thing as that. So times our E, we just put in our E, 1 times 10 raised to the power of 7. So, and our final answer here will now be 1.6 times 1 will give us 1.6, then times minus 19 plus 7, that should give us 12. And this should give us okay, or we can actually give us in Newton, since we are talking about the force here. Alright, so now the acceleration, which will give us F equals what? Ma, and our A will give us what? F all over what? Mass. And our force just giving us 1.6 times 10 to the power minus 12 Newton all over the mass of the electron, 9.1 times 10 to the power minus 31. So, and this will give us 1.6 all over 1.9 times 10 to the power minus 12 plus 31. So here we get to have 1.6 now divided by 9.1. So we get to have to be 0.175, okay, approximately 6, then times 31 minus 12 should give us 19. So this will give us 1.76. Okay, yeah, no, 1 point, yeah, when we choose this 0 here, 1.76 times 10 raised to the power of now this should be, that's minus 1, that will be 18, then meter per second square for the acceleration. Okay, so that's that. Now let's look at this question, and the question says that the resultant capacitance in the diagram below is. Now looking at this is a circuit containing capacitance, I mean capacitor 1, 2, 3, 4, 5 capacitors. Now looking at this, 2 microfarad and 3 microfarad are in series. Now are in series with 4 microfarad. Now this 1, 2, 3 now is in series to this parallel combination 2 and 4 respectively. Then how do we do this? Now first of all, take note that for series combination in a capacitor, you have 1 all over C, 1 over C1 plus 1 over C2 plus 1 over C3. Now I end up with 1, 2, 3, 4. So we then have 1 over 4. Okay. Now let me use this one as 1, 2, then 3 and 4. Now but for the fourth one here is parallel. Okay. So for the parallel combination, we have what? C1 plus what? C2. Okay. Now since C3 is actually for the parallel combination, let us do it like this. C3 then equals, let me use C2 and C4. I hope you get to understand that. Okay, so let us now replace C3 for this. So this, the above equation now become 1 over C, then equals 1 over C1 plus 1 over C2 now plus 1 all over C2 plus C4, and that C4 is actually this one and this one. Okay, so okay, let me do like this. C1 is what? 2, C2 is 3. Now for here, since we are replacing 6, 3 for 2 and 4, which is 2 and 4, that will be 2 plus 4, then plus the C4, that will be 1 all over 4. Okay, all right, so let us now solve. So now 2 plus 4 will actually give us 6. So let's just make this one 6. Now finding the LCM, and this is 2, 3, 6, and I guess the common factor that can go through all is 12. So 2 in 12 is 6 here, 3 in 12 is 4, 6 in 12 is 2, and 4 in 12 is 3. So we end up having 6, 10 plus 5, that will be 15 all over what? 12. So 1 over C equals to 15 all over 12. 3 here, 4, 3 here, then 5. We end up having 1 over C equals to what? 5 all over 4, which is C. Since we have 1 over C, then our C will now become 4 over what? 5. Now dividing through, this will be 4. I mean 5 in 4 is impossible. Then you have 0. Then 5 in 40 you have what? 8. Sorry. Now let's look at this question here. At the potential difference across the 3 capacitors respectively are. Now here is the circuit. Now we're given the potential difference here for the overall potential difference is 12 volts, and here are the capacitors in series. So let's say this is C1, C2, and C3. Now, because they are in series, they will definitely have a common charge flowing through them. Now, but the voltage at which the three operate will definitely be different. The V1, V2, and V3. Okay. Now, first of all, what we just need to do here now is to find the circuit charge. Okay. Okay. Let us first of all find the effective capacitance of the circuit. And since these three capacitors are in series, so here we have 1 all over C. C represents the effective capacitance, 1 over C1 plus 1 over C2 plus 1 over what, C3. So to this time, we have 1 all over C1 is 2 plus 1 all over C2 is 6 plus 1 all over then 3. Now let's find the LCM, which is 6. Here we have 3 plus 1 plus 2. Okay, that is 2 in 6 will give us 3, 6 in 6 will give us 1, 3 in 6 will give us what, 2. So we end up having 6 all over 6, and that because 3 plus 1 plus 2 give us 6. Okay, so here we have 1 all over C. So, and 6 here, 1, 6 here, 1. So 1 all over C, which is the effective capacitance, will give us 1, which actually implies that the effective capacitance is what? 1. Okay, now let us recall that in a circuit containing capacitors, charge equals to what? CV. Okay, where C is the capacitance and V is the potential difference. Now let's calculate for the value of charge flowing through them. So, and this will give us the charge here, the effective capacitance is 1, then times the overall volt, that will be 12, which will give us what? 12. Okay, now to this time now, let us now find the potential difference across each of the capacitor C1, C2, C3. Now from this formula here, now C1, now V1. Okay, so making V1 the square root of formula, we get to have that V1 equals whatever was C1, and applying this rule to every other one. So we have that V2 equals to the charge over our C2, and V3 will give us charge over our C3. So now be 12 all over C1 is what, 2, which will give us what, 6 volts, and this will give us 12 all over C2, which is 6, will give us 2 volts, and 12 all over C3, which is 3, that will give us what, 4 volts. Okay, and if you add everything together, you have 6, this 8 plus 4, which is this. Now it implies here that as the charge flows, now for C1, for C3, 4 volts, 4 volts, now C2, 2 volts, and V1, for C1, 6 volts. All right, now let's look at this question again, and here it says an electron of charge 1.6 times 10 to the power of minus 19 coulombs and mass 9.1 times 10 to the power of minus 31 kilogram is accelerated between two metal plates with velocity of 4 times 10 to the power of 7 meters per second. Now the potential difference between the plates is. Okay, now first of all, we just need, let us write out the parameters. Now the charge Q is giving us 1.6 times 10 to the power minus 19 coulombs. Now the mass of the electron is 9.1 times 10 to the power minus 31 kilogram. The velocity 4 times 10 to the power of 7 meter per second. Okay, and we are asked to find the potential difference V. Okay, now what equation relates all these terms? Now take note. Let us assume this is the two plates. Now an electron is accelerated between them. Okay, which means there is a work done for the electron to have probably moved from here to B. Okay, which involves what? Energy. Now to this point, now we can actually see that the energy here now equals to the product of the charge times the potential difference. Variably, we actually know that work done equals to what? Charge equals to the product of charge times and the potential difference. Okay, but this work here expelled what? Energy, and that energy in form of what? Kinetic energy. So here our E here will be equated to the what? The kinetic energy. That will be 1 all over 2 mass V squared equals what? QV. Now this is actually velocity, and this is what? Potential difference. And we are told to make to find the value of the potential difference. So which means let us divide both sides by Q. This, then our V, which is our potential difference, becomes mv squared all over 2Q. Alright, so to this end, when I say that V, that's the potential difference, equals mass, that will be 9.1 times 10 to the power of minus 31 times the velocity 4 times 10 to the power of 7 all to the power of 2, then all over 2 times our charge 1.6 times 10 to the power of minus 19. Okay, to this end, our V now becomes 9.1 times 10 to the power minus 31. Let's open the bracket here. That will become 16 times 10 to the power of 4. 2 times this 4 will be raised to the power of 2, and this exponent will multiply by 2, which will give us 14. Then all over, now 2 times 1.6, that should give us 3.2. 3.2 times 10 to the power minus what? 19. Okay, moving further here, our V becomes, now let us probably use our calculator. Now 9.1 times 16, 9.1 times 16 will give us 145.6, then times 10. Now minus 31 plus 14. And that should give us 17 here, minus 17. Then all over 3.2. Now 10 raised to the power of minus 19, bringing it over to the numerator, our 19 becomes plus. So this will, we are left with 1.5.6 divided by 3.2. So this will give us 45.5 times 10 raised to the power of, here we have that will be 2, right? That will be minus 17 plus 19, that should give us 2. Okay, so bringing our decimal to this point, now plus 1, so here we have 4.55 times 10 raised to the power what? 3 volts. Alright. Now let us look at this question once again, and it says under electrostatics, and it says calculate the electric field strength at a point 0.05 meter from a point charge of magnitude 3.14 times 10 raised to the power of minus 6 coulomb in a medium of permittivity 2.5 times 10 raised to the power of minus 11 per Newton per meter square. Now first of all, let us write all the parameter out. We are given that R is given as 0.05 meter. Okay. The charge Q now is given as 3.14 times 10 raised to the power minus 6 coulomb, and permittivity of the medium is 2.5 times 10 raised to the power minus 11, then per Newton per meter square. Now we are asked to find the electric field force. Alright, what we now need to figure out now is the relationship, the formula that connect electric field, permittivity of the medium, a distance, and the charge. Alright, and here is that formula. E equals Q all over 4 pi epsilon naught R squared. Alright, now this is the formula. Okay, so let us just plug in the value of all these parameters into the equation, and which is actually the right hand of the equation. Here we have that E equals, our charge here is 3.14 times 10 to the power minus 6, then all over 4, then times our pi. Okay, let's make use of 22 over 7. Now times epsilon naught, that will be 2.5 times 10 raised to the power minus 11, then times our radius, that will be 0.05 all raised to the power of what? 2. Okay, now let us see how we simplify this. So here we have 3.14 times 10 raised to the power minus 6, then all over. Now punching our calculator here, 22 divided by 7, which is this, now times 4, okay, will give us 12.54. Now times 2.5, this will give us 31.423. okay, so here we have, let us, the whole of this is 31.4 approximately 3. Now times 10 raised to the power of minus 11. Now this guy here, 0.05 raised to the power of 2 will give us times 2.5 times 10 raised to the power of minus 3. Okay, now let us do this. Since here we have 3.14, now let us reduce this also 3 points. So here you have 3.14 times 10 raised to the power minus 6, then all over. Okay, let us just multiply this and this. So here you have 31.43, then times 2.5. Then here you have 78.575, then times, now here we have 10. Now let us raise to the power of this minus 11 minus 3 will give us minus 14. So there we have it. So you can say here this is 3.14. okay, now times 10 raised to the power minus 6. Now let us bring this one over to the denominator. Then you get to have that this negative 14 will become plus 14, then all over 78.575. Now which will give us 3.14, now divided by denominator here, 78.575. So that will give us 0.0399, then times 10 raised to the power of minus 16 plus 4. That should give us plus 14. I guess that should give us a, okay, 14. That one skipped my memory. Okay, that would be 8. So let us count. This is 1, 2. So this will be minus 2. Then here you have 3.99 times 10 raised to the power of what? 6. Alright, thank you and God bless you. Now before us is this question in electrostatics, and here it says that an electron at a distance of 5.0 times 10 raised to the power of minus 11 meter away from the center of a proton. Now calculate the electrostatic force on it. Now the charge on the electron is equal to minus 1.6 times 10 raised to the power of 19 coulombs, and that of the proton is given as this, and here we have our constant to be equals to this value. Alright, first of all, what we just need to do here, let us recall the Coulomb's equation, which is F then equals to K. Now the charge 1, charge 2 all over R squared. Now let's take note that our K is actually equals to 1 all over 4 pi epsilon naught, which is actually the permittivity of the medium. Now, but the whole of this is given as 9.0 times 10 to the power what? 9. Alright, for us to do this, now take note that we've actually been given all the parameters in the right side of the equation, where our K is 9 times 10 to the power what? 9, then times our Q1 1.6 times 10 raised to the power of minus 19 times, okay, let me just use multiplication. So 1.6 times 10 raised to the power of minus 19, then all over now 5 times 10 raised to the power of minus 11, all raised to the power of what? 2. Okay, all we just need to do here now is simple. So here you have 9. Now times 1.6 times 1.6, then times, now all this, the exponents just come together, 9 minus 19 minus 19, then all over 5, now to this hand. So here you have this actually give us 5 raised to the power of 2 times 10 raised to the power of minus 1 raised to the power of 2, which will give us 25 times 10 raised to the power of minus 22. Okay, and so here we have 25 times 10 raised to the power of minus 22. Moving further, and this will now give us 9 times 1.6 times 1.6 times, now let us bring this 10 raised to the power of minus 22 over to the numerator. So you get, let's write this one first, minus 19, then plus 22, then all over 25. Alright, if we tend to punch our calculator, now we get to have now this value. So you get to have 23.04 times 10 raised to the power of, now here you have this is 9, then the whole of this will give us minus 38 plus 22. Alright, minus 38 plus 22 will give us minus 16. So 9 minus 16 actually give us minus 7. So here you have minus 7, then all over 25. So 23.04 divided by 25. So you get 0.9216 times 10 raised to the power minus 7 Newton. Alright, final answer. If you love what I've just done, subscribe to my YouTube channel and ensure you share this video to others. Thank you and God bless you.